logarithm. So remember from the last class that when you take the derivative of a natural log, that there is no function existing for y equals natural log of x after the y-axis. So x can't be 0, and x can be negative. So that means when we find the derivative is 1 over x, that we are only actually allowed to have one side of the function. However, when we're going backwards, which we're going to do today, we're actually starting with y prime equals 1 over x with no other restrictions, which means that that graph actually exists for everywhere except x is not 0. So that means when we get y, which is the antiderivative, we have to end up with a two-sided function. So that means that our two-sided function has to become natural log of the absolute value of x plus c. So the absolute value changes the function to natural log just by making the left-hand side 0. So that's the only change that's going to happen. So now we also just have x can't be 0. So when we're anti-derivating, we're looking for natural log to be 1 over a linear pattern. So if I have 1 over the square root of u, or 1 over the square root of x type, these are not natural log. So remember last class when we had logarithms, if we had a power, we always pulled the power down, multiplied with the front, so it would no longer be there. So it's only 1 over linear, so either 1 over x or 1 over u. So for number 1, I would factor out the 4 and have 1 over x dx. So when you're anti-deriving, you cannot do this as x to the negative 1, because that would be x to the 0 over 0. That's not possible. So you have to ask yourself, which of these special functions has a derivative of 1 over x, and the function with a derivative of 1 over x is natural log of absolute value of x plus c. For number 2, I'm looking for either 1 over x or 1 over u. So u has to be 5x minus 2. So du is 5 dx. That means 1/5 of du is going to go over dx. So the antiderivative of 1 over linear is always natural log absolute value of u plus c. So it's 1/5 natural log absolute value of 5x minus 2 plus c. The next one, my u, would have to be 3 minus 6x. So du is negative 6 dx. So negative 1/6 du is going to go over dx. So if I factor out the 4, I have 1 over u, and dx is negative 1/6 du. So I have negative 2/3 natural log absolute value of u plus c. So negative 2/3 natural log absolute value of 3 minus 6x plus c. For number 4, our u is going to be x squared minus 4. Our du is 2x dx. So I have 1/2 du to replace x dx. So notice this wasn't initially a linear on the bottom, but it does fit the pattern of having the u prime over u, or 1 over u du, because the power on the bottom is higher than the power on the top. So we have a u du over u situation. So I'm going to pull out the 7, keep the half from the du, and have 1/2 du over u. So 7/2 natural log absolute value of u plus c. So 7/2 natural log absolute value of x squared minus 4 plus c. Okay, now, not every fraction is going to be a natural log. Like I said earlier, you need a linear situation, so either have something that is u prime over u, so that I can convert it to a linear, so it's just 1 over plain u, or it has to be 1 over x, but linear or something that is u prime over u that could be linear. Okay, but not every fraction is. So the first thing that I tend to look for is there an inside part. If there's an inside part, then it's regular u sub. if there's not an inside part, can I simplify and get rid of the fractions? If I can't simplify and there's no inside-outside, then I look for the natural log to be 1 over u du, or u prime over u. After that, and only after that, I would look for this to be inverse trig. So inverse sine, or inverse cosine, or inverse tangent. So for number 5, I have a definitive inside-outside situation because of the square root. So u is going to be the inside part. Du is going to be negative 2x dx. So negative 1/2 du is a man-to-man substitution for x dx. So I have negative 1/2. Negative 1/2 integral of du over the square root of u. That is absolutely not natural log. You cannot have roots or other powers with natural log. Natural log has to be u to the first power. So I'm going to use the regular power rule on this. So this is negative 1/2, the integral of u to the negative half du. So it's negative 1/2. The power rule says I add 1, so I get a half, and divide by a half, plus c. So I have negative square root of u, which is 16 minus x squared, plus c. Similarly, for number 6, my u is definitely an inside part. So that means if I choose my u to be 2x minus 1, I already have now, I have 1 over the cube root of u. So now we have to substitute dx. So du is 2 dx. So 1/2 du goes into dx. I have 1/2 du. Again, this is not natural log because it has a different power than 1. So I'm going to rewrite it using the power rule. And the power rule says we anti-derive by adding 1 and dividing. So now we have 3/4 the u, which is 2x minus 1, to the 2/3 power, plus c. For the next one, I also notice that I have a definite inside-outside part. So the inside part is going to be the natural log of x. So what I've decided now is that I have u to the 4th. What's left is the x dx, but it's x on bottom. So the derivative of u is 1 over x dx, which is exactly what I have. So I'm going to substitute in, use the power rule by adding and dividing, plus c. So this will be written as 1/5, the natural log of x all to the 5th, plus c. Now, if I don't have an inside part, the next thing is to try to simplify before I do anything else. So I'm going to rewrite this as x squared over x minus 2x over x plus 1 over x dx. This simplifies to be x squared minus 2. I'm going to leave that as 1 over x because I know the antiderivative of 1 over x. So x cubed over 3 minus 2x plus the natural log of the absolute value of x plus c. Okay, so this next one, I'm going to rewrite this so that it's a fraction. So that I have sine of x over cosine of x dx. Du will never, ever, ever be on the bottom. So that means that my u has to be the bottom. And the derivative of u is negative sine x dx. So negative du is what I could substitute in for sine x dx. That means I have negative du over u, and negative 1 over u du. And 1 over linear is always natural log, absolute value at the bottom, plus c. So negative natural log, absolute value cosine x plus c. this were a free response question, this would be acceptable. On a multiple choice, however, a lot of times they would move that power up. So remember when we had b, natural log of a, we said the power could come up or down, and so that would be the natural log of a raised to b. We can do the same thing. That means that I get cosine of x on the inside raised to the -1, not the inverse. So 1 over cosine is actually secant. So I could rewrite this as natural log absolute value of secant, and I no longer have a negative. Okay. I'll do the next one similarly, so that we have the antiderivative of cosine of 3x over sine of 3x dx. So again, the bottom has to be my u because the bottom is not allowed to be du. So u is the sine of 3x. Du is 3 cosine of 3x because of the chain rule dx. So I have exactly 1 over u du, except for this 3, which if I divide over x a third. So I have 1/3 natural log absolute value of u plus c, which is 1/3 natural log absolute value of sine of 3x rather, plus c. So you didn't want to see the 1/3 moved up, it's just the negative sign that gets moved. For the next one, again my u is on the bottom. My du is then cosine of x dx, which is perfect. So I actually have du over u, which is natural log absolute value of u plus c. So the natural log of the absolute value of the bottom over u plus c, which would be correct on a free response, but you would probably see them leave the absolute value symbol off on a multiple choice because of the fact that sine plus 2 is going to be sine shifted up to would always be positive. Okay, on this last one, it's one of those situations where you want to recognize if I see natural log of x and 1 over x together, I know that the natural log is u and the derivative of natural log is 1 over x. In this situation, when I see tangent, I need to look for his derivative, which is secant squared. Even if I had secant, the derivative of secant would be secant tangent. So secant and tangent always go together. So I'm going to rewrite this so that 1 over cosine squared is actually just secant squared x, but I still have 1 over tangent. So my u is going to be the tangent of x because du is never on the bottom. So then du is secant squared x dx. That means I have exactly 1 over u du. That's the natural log absolute value of u plus c, which is the natural log of the absolute value of tangent of x plus c. My u is going to be 2x plus 1. So my du is 2 dx. So if my x is 4 and my x is 0 initially, my u is going to be 9 and my u is going to be 1. So I have a 4 that I can factor out. I have 1 over u decided. So I've done these two pieces. And I now have to do dx. So 1/2 of the u is dx. So I put half in du. So we have 2, the antiderivative of 1 over u is natural log of u, absolute values, plus c. So 2 natural log absolute value, 2x plus 1, plus c. Okay, so like I said with tangent and secant, you really want to know that those are always partnered up. So when I see natural log and 1 over x together, I know that natural log has to be the u. So that the du is the 1 over x dx. So what I have here, x equals b squared and x equals b. My u is the natural log of b squared, so 2. And u is the natural log of b, so 1. So we have 1 to 2. I have the natural log on bottom as my u. And 1 over x dx is just plain u. I'm substituting it here. So remember, du is never, ever on the bottom. So we have natural log absolute value of u from 1 to 2, which is natural log absolute value of 2 minus natural log absolute value of 1. Natural log of 1 is always 0, so we're really left with just natural log of 2. For the next one, we have 1 plus cosine of x for the u. So du is negative sine x dx, which means negative du is equal to sine x dx. So we have the integral of negative du over u. We change our shoes by putting these into here. So 1 plus cosine of 5 of 2 is just 1. 1 plus cosine of 0 is 1 plus 1, so 2. So we have to flip. So positive from 1 to 2, 1 over u to u. Is natural log absolute value of u from 1 to 2. And because we have limits, we never, ever get back together with our x. The natural log of 1 is 0. So we just have natural log of 2 again. Okay, for this one, for this next problem, we have u equal to x plus 2. So du is equal to 1 dx. So if I factor out the 2, I have 1 over u du. That means I have 2 natural log absolute value of u plus c. So 2 natural log absolute value of x plus 2 plus c. So the next problem, this is definitely not something we would want to try to simplify. So we need to look for a u prime and a u. So if we look at this part as u, e to the x plus e to the negative x, then the top part, e to the x minus e to the negative x, is exactly du. So we'll be anti-deriving 1 over u du. That gives us the natural log absolute value of u plus c. So the natural log of the absolute value of e to the x plus e to the negative x plus c. On a free response, this would be an acceptable answer. On the multiple choice, it would actually probably drop the absolute value symbols because what's inside is always positive. So we wouldn't actually need the absolute value sign. For the next question, our u is going to be the bottom, 4 minus e to the x. So we have 1 over u. And the du is negative e to the x dx. So negative du equals e to the x dx. So we have a negative and a du. So we have negative natural log absolute value of u plus c. So negative natural log absolute value of 4 minus e to the x plus c. So negative e to the x is going to be negative, so we want to make sure that we do have the absolute value here. Now remember, not all of these questions, every time you see a fraction, are going to be natural log. So this time I have an inside again. So my u is 1 plus 1 over t. So du is the derivative of 1, which is 0. The derivative of 1 over t, which we could think of as t to the negative 1, is negative t to the negative 2. Negative t to the negative 2, or negative 1 over t squared dt. So we have exactly u squared, but then the 1 over t squared has a negative in front, so we'll do negative du, so that we have a perfect substitution. So we have negative using the power rule, it's u cubed over 3 plus c. So negative 1/3 u cubed plus c. So that would be negative 1/3 So 1 plus 1 over t cubed plus c. And again, just because there's a fraction does not mean you have natural log. I have an inside part, so u equals 3 minus 5x. Du then is negative 5 dx. So negative 1/5 du equals dx. U equals 3 minus 5. If I substitute in the x, I'm going to get 3 minus 10, so negative 7. U equals 3 minus 5 times x, so then I would have negative 2. That makes my integral negative 1/5 from negative 2 to negative 7 du over u squared. So this is u to the negative 2, which is not natural log. So when I anti-derive, I can flip this, make this positive, if I change this to negative 7 and negative 2. I anti-derive and I get 1/5 u to the negative 1 over negative 1 from negative 7 to negative 2. So that's 1/5. The negative I can bring out and just do 1 over u from negative 7 to negative 2. So I have negative 1/5, 1 over negative 2 minus 1 over negative 7. So if I were to distribute and simplify, I get 1 over 14. This next question, remember you're looking for the relationship between natural log and whatever else is there. So we're going to choose the natural log to be the u. So the du is 1 over x dx. So we have exactly u du. Remember, du never goes on the bottom. So now, substituting in, the u value is the natural log of e, so 1, and the bottom u is the natural log of 1, so 0. So I have u squared over 2 from 0 to 1, which is going to be 1 over 2 minus 0 over 2, so just a half. So for cotangent, we'll rewrite that as cosine over sine dx. So now my u is sine x because du is never on the bottom. So we have du over u, or 1 over u du, which becomes natural log absolute value of u plus c. So natural log absolute value of sine x plus c. Okay, so remember we said that if e is not inside something else, then e is automatically e to the u. So our u has to be sine of x. So I have e to the u. And we're going to rewrite this. 1 over secant is really the same thing as cosine. So now when I do the du, I do get cosine of x dx. So I have a perfect e to the u du. So that becomes e to the u plus c, which in this case is e to the sine x plus c. For this next one, we are not able to simplify. Even if we did factor, we can't cancel anything. So on here, we want to notice that the powers are different. So it's very similar to number 22. You have one of them is the derivative, one of them is the u. So this whole part has to be my u because it has the higher power. So my du is going to be 2x dx. So 1/2 du equals x dx. So we have 1/2 du over u, or 1/2 1 over u times du. That means we have 1/2 natural log absolute value of u plus c, which is 1/2 natural log absolute value of x squared minus 1 plus c. For the next part, we have a similar situation, the higher power on bottom. So our u is going to be 5 minus x cubed. So our du is negative 3x squared dx. So I have negative 1/3 du is x squared dx. So I have negative 1/3 du over u. So negative 1/3 natural log absolute value of u plus c. So negative 1/3 natural log absolute value of 5 minus x cubed plus c. For the next one, we have a power on the bottom that's a root. That is impossible for that to be a logarithm. Okay, so we're going to have this as u equals x squared plus 1, du equals 2x dx. So 1/2 du is x dx. So I have a half of du on the top and the cube root of u on the bottom. So remember, that's really like having u to the negative 1/3. So we're going to use the power rule. So u becomes adding 1, dividing by 2/3 is the same as multiplying by 3/2 plus c. So we have 3/4 u to the 2/3 plus c. Number 27 can be simplified. X squared over x minus 3x over x minus 5 over x dx. So x minus 3 minus 5 times 1 over x dx. So it's x squared over 2 minus 3x minus 5 natural log absolute value of x plus c. Okay, for the next one, we have an inside part. So the inside is always going to be our u, unless we simplify. So du equals 1 over x dx. So I have u to the 5th du, which is 1/6 u to the 6th plus c. So 1/6 natural log of x all to the 6th plus c. For the next one, the bottom is going to be u. So du is 2x minus 5 dx. So I have exactly 1 over u du. So natural log absolute value of u plus c. So natural log absolute value of x squared minus 5x minus 1 plus c. And the next one, I have my u on the bottom. So u is x squared plus 8x minus 3. Du is 2x plus 8 dx. So 1/2 of du is going to be x plus 4. So I have to divide the whole thing, dx. So I have 1/2 du over u. So that's almost forgot my half. 1/2 natural log absolute value of u plus c. So 1/2 natural log absolute value of x squared plus 8x minus 3 plus c. Okay, so in this situation for number 31, we want to make sure we're checking for a relationship. And if u is natural log of x, then du is 1 over x dx. If I factor out the 5, I have here 1 over x, which is exactly du, and I have natural log of x on the bottom. So that's u. So I have 5 natural log of u, absolute value of u plus c, which is 5 natural log absolute value of the natural log of x plus c. I'm going to rewrite tangent of 4 phi is sine 4 phi over cosine 4 phi d phi. So my u is going to be the bottom because du is never on the bottom. So du has to be negative sine of 4 phi d phi. So negative du can go in for sine of 4 phi d phi. So I have negative du over u, which is negative natural log absolute value of u plus c. So negative natural log absolute value of cosine 4 phi plus c, which remember we said was actually equivalent to natural log absolute value of secant 4 phi plus c. Okay, for number 33, my u is the bottom because du is never on the bottom. So u is 4 minus 3 cosine theta. Du is then negative 3. The derivative of cosine becomes positive. Now sine theta d theta. So 1/3 du is sine theta d theta. So I have 1/3 du over u, which is 1/3 natural log absolute value of u plus c. So 1/3 natural log absolute value of 4 minus 3 cosine theta plus c. Okay, so for here, I'm going to pull out the 2. So I have 1 on top. My u is going to be 2x plus 1. My du is going to be 2 dx. So 1/2 of du is equal to dx. My shoes get changed out. So if I substitute 4 in for x, I get 9. If I substitute 0 in for x, I get 1. So I have 1 to 9 with a 2 outside. And now this part gives me divided by 2. And then it's 1 over u du. So we have just the natural log absolute value of u from 1 to 9. And like Taylor Swift, we never, ever, ever get back together with our x because we have limits. So remember, the natural log of 1 is 0. So our answer is just natural log of 9. Okay, whenever we have an inside part, we should always check to see if that is our u first step. So u equals 1 plus natural log of x. Du then is 1 over x dx. So we have exactly u cubed du. I'm going to change out. If I put my limits into my x, I get 1 plus the natural log of e, which is 1 plus 1, so 2. 1 plus the natural log of 1 is 1 plus 0, so 1. So we're going to antiderive u to the 4th over 4 from 1 to 2. I'm going to pull out the 1/4 because I think it makes it easier. And then have this as 2 to the 4th minus 1 to the 4th. So then it's 15 over 4. For my next problem, the whole bottom is my u. So my du is 1 minus sine x. So that's actually a perfect u substitution as 1 over u du. Now substituting in, I get pi over 2 plus cosine of pi over 2, which is 0. So pi over 2 it is. And then if I substitute 0 in, I get 0 plus cosine of 0, which is 1, so just 1. So we have the natural log absolute value of u from 1 to pi over 2. So that's the natural log of pi over 2 minus the natural log of 1. Natural log of 1 is 0. So our final answer could be written as the natural log of pi over 2, or the natural log of pi minus the natural log of 2, which you will see frequently done. Okay, for number 37, I would simplify first. X plus 1, x minus 1 are the factors. With x plus 1 would then cancel. So now all I have to do is antiderive x minus 1 dx. So using the power rule, that's x squared over 2 minus x from 1 to 2. So I get 4 over 2 minus 2 minus 1 over 2 minus 1. So I get 2 minus 2 and negative a half. So I end up with positive a half as my answer. Okay. For the next one, you're actually doing the fundamental theorem of calculus, part 1. We are looking for the derivative of an integral. So the derivative cancels the integral, but we still have to plug in. So 1 over x times the derivative of x minus 1 over 1 times the derivative of 1. So 1 becomes t, so the derivative of 1 becomes derivative of t. If x goes in for t, then the derivative of x, which is 1, goes in. So we have 1 over x. So you should not have to antiderive that. Okay. Using my calculator, if big f of x is the antiderivative, I would write that as the antiderivative of natural log of x cubed over x dx equals big f of x. So if I start from 1 and stop at 9, that gives me from 1 to 9. Does not give me f of 9. It does not give me f of 1. It gives me the difference, or the total change. So that means that this is actually going to give me f of 9 minus, in this particular case, 0. So if we do the integral with our calculator, we should get f of 9 minus 0. So if I do the integral, starting at x is 1 and stopping at x is 9, of the fraction, of parentheses, natural log of x, close the natural log, close the parentheses, cube the natural log function, divided by x dx. I get 5.827 minus 0. Now, on this one, it says the definite integral using first approximating using inscribed rectangles. Okay, so e to the x squared looks like this. We're only going from 0 over to 2 using 2 inscribed rectangles. So inscribed means it can't go over. So for that to be true, we're going to have to do the left with n equals 2. And it says to repeat the process and do an approximation with the trapezoidal with n equals 2. So then we're going to do trap with n equals 2. And it says, what is the difference between these two methods? You should not do any of this by hand. You should use your calculator. So I'm going to put into my y equals e to the x squared. I'm then going to run the program for Riemann. I did store into my y1, so I can continue. I don't really need to draw pictures, so I'm going to say no for that. The left endpoint is the bottom of the integral. The right endpoint is the top of the integral. We are choosing first to do the left with n equal to 2. So we get 3.71828. Whoa, hi buddy. We're then going to repeat the process by pressing enter. We're going to change the method. And we're going to choose to do trapezoids this time because that's what they told us to do, with n equal to 2 again. So let me make sure that we did this. So we're going to change the method. Okay, so left endpoint, right endpoint, left side, n equals 2. Repeat the process to change the method. We're doing trapezoids, and with 2 again. So, on here, our trapezoidal, 30.517, 36, is very, very different from our left side. The trapezoid's going to hug the curve much better for this one. So I'm going to quit and do, oops, do 30.517 minus 3.718, and 26.799 is approximately 26.0. So very different answers. Okay, for number 41, it asks how far the particle travels from time 0 to time 2. Okay, total distance traveled is actually this. It's the integral of the absolute value of velocity with respect to time from 0 to 2. So it's speed times time, total distance traveled. Since E is always positive, greater than 0, E is always positive, that means that we could really ignore the absolute value. Antiderivative of positive E is still positive E from 0 to 2. So it's E to the 2 minus E to the 0, or E to the 2 minus 1. My pen is not cooperating. Okay, so A. So on our last page, remember we rewrite cotangent and tangent. Those are the only two we have to consistently rewrite as sine over cosine. So our u has to be the bottom because du is never on the bottom. So du is negative sine of 3x times 3 dx. So negative 1/3 du goes in for sine of 3x dx. So negative 1/3 du over u is negative 1/3 natural log absolute value of u plus c. So negative 1/3 natural log absolute value of cosine of 3x plus c. They will put the negative power back up. So we have 1/3 natural log absolute value plus c, but instead of it being cosine, the negative power flips the cosine, making it secant. Okay, remember the area bounded between a curve and the x-axis is just the integral. So we're going to integrate e to the x over 2 plus e to the x dx from 0 to 1. So our u is going to be 2 plus e to the x. du is e to the x dx. So if we substitute 1 in, we get 2 plus e to the 1. If we substitute 0 in, we get 2 plus